Good morning, everyone. Thanks for joining us. My name is Bowden Fisher with the Ohio Department of Agriculture, Division of Soil and Water Conservation. It is 9 o'clock, so we'll go ahead and get started here. Respect all of your time. Couple notes as we get started here. Your microphones should all be muted, but if not, please make sure to do that to ensure the experience is good for everybody, and turn off your cameras, please. If you do have questions throughout the webinar, you're welcome to push the raise hand function, and then we can unmute you to ask your question verbally. Or if you do want to just type your question in the chat, that will work as well. So again, thank you for joining us for the 2024 Rollout webinar for the H2Ohio Conservation Ditch Grant Program. This will be our third iteration of the program this year, and we're going to give you an overview and update of the H2Ohio program for a few moments as we start, and then we'll get into the specifics of the conservation ditch program that you're all here for. We did send out some materials ahead of the webinar. If you did not receive those, please feel free to reach out after the session. So as we get started here, I'd like to introduce Terry Mesher, also with the Ohio Department of Agriculture. He is the program manager for the H2Ohio program, and he's going to give us an overview and update of where the program stands overall and some additional comments. So I'll go ahead and hand it over to you, Terry.
Well, thank you, Bowden. Good morning, everybody. Appreciate everybody joining in this morning. I'm going to give a real brief overview of what H2Ohio and the intentions of H2Ohio are. H2Ohio is first and foremost a water quality program that was spurred on and initiated probably by some of the water quality concerns and algae concerns centered around Lake Erie. But certainly H2Ohio is a program for across the entire state of Ohio. For us at the Department of Agriculture, looking at the rural landscape, looking at agricultural land, cropland, our main focus is and is going to continue to be to reduce nutrient and sediment loads coming from agricultural land, primarily phosphorus, nitrogen, and sediment as we move forward. When we look at what we've done in the past, over the past several decades in the conservation world, we have done a wonderful job of reducing sediment over the years. In the last 10 to 15 years, phosphorus and nitrogen loading has proven to be a challenge, and certainly a water quality issue across all of the Midwest and certainly here in Ohio. If we look at the different areas of Ohio, it depends on what nutrient, the area that we're in Ohio will dictate the primary nutrient that we're looking at. If we're going into the Lake Erie Basin, and our primary focus is phosphorus. If we're looking at the Ohio River Basin, the dead zone down in the Gulf of Mexico dictates that nitrogen probably takes the lead role. But that said, the practices that we're focusing on for H2Ohio focus both on nitrogen and phosphorus and the reduction thereof. Most of what we've done to date has been focused on nutrient management plans and fertility management within the row crop production. In 2022, we took our first venture into designing and installing and incentivizing the construction of two-stage and overwide channels. Looking forward, I think these channels are going to continue to grow and probably take a larger portion and get a bigger focus of what we're doing within H2Ohio. Certainly can't quote any of the research community, but I think what we have been learning in Northwest Ohio is that overall the nutrient management practices that are typical in the region are probably a little bit higher or better than what would have been anticipated 8 and 10 years ago. And as we look at that, that means that the reductions that we can accomplish through the nutrient management side of it probably aren't quite as large as what we would have originally anticipated. Not that there's no improvements to be made there. There certainly are, but the gains in load reductions probably aren't as significant as what we would have thought 5 and 6 years ago. So that said, we are looking at other practices the conservation ditches and other structural practices to help manage water, help process nutrients, and help settle out sediment are certainly going to be a growing part of our overall H2Ohio program as we move forward. So with that, I think looking forward, we've got funds to commit to it for 2024. Longer range, I think ODA is going to continue to put funds to this effort overall. I think it's a very good practice to help manage water, not only accomplish drainage, but also manage water, provide some storage, as well as reduce sediment and nutrient loads going downstream. A little bit longer term view, there is some discussions at the state level about the possibility of a bond, water quality bond. And if that discussion continues and if a water quality bond becomes a reality, ODA would certainly be looking at funding these types of structures for the water quality improvements that they provide, as well as continuing developing the research so we can also estimate and assess what the overall impact is from a water quality standpoint for these practices. So with that, Bowden, Justin, I'll hand it back to you, and I appreciate everybody attending today. Thank you.
Great. Thank you, Terry. Thanks for the good overview. We do have Justin McBride here with us as well. Justin is the H2Ohio lead engineer for our division and the department, and he is, if you've been involved in the past couple of years of this webinar, Justin's going to do a similar overview here today about the details of the grant itself, go over the application form, the design, process and example, and common issues that we have run into up to this point, as well as some other topics. So I will go ahead and hand it over to you, Justin. And again, if you have questions throughout Justin's session, please put them in the chat or raise your hand and we will get to those.
All right, thanks, Bowden. Okay, I'll start out by echoing what Bowden had mentioned earlier. This is our third year for the conservation ditch program. Some of you on the call have been on the webinars in the past years. A lot of this is going to be very similar or identical to those past years, but I know there's a fair amount of folks on the call who are now have gotten interested after hearing successes we've had and participate in this program. So I'm going to rehash a lot of what some of you have already heard, just so that everyone hears the same thing again. But for those of you that have heard this before, there is one significant change this year that I'll go through, which hopefully is a positive change, but I'll get to that here in a second. Okay, this first slide, the first thing I'll mention is the last three bullets we're not going to hit this time. John Witter's not able to present with us today. He covered those with OSU last year, but if you are interested in those pieces of information, I'll hit this again at the end of the webinar, but go back to the 2023 webinar on our YouTube page and you can see those parts that he presented back then. All right, so this program, before I get into the theory and the idea of a conservation ditch, this program provides funding for drainage projects, ditch projects in particular. Those of you at the county level, there's a lot of county engineers on this call. There might be some county commissioners. There's a lot of soil and water districts here. You get drainage complaints all the time. You get folks always wanting to clean a ditch. But when it comes through the petition process, there's a number of hurdles, as you know, and not everything gets to the final conclusion where you get an improvement in the drainage infrastructure that was there before. So this program will do that. It'll provide funding to help limit the amount of concerns from the benefiting landowners who would otherwise have to pay for the construction of the ditch. And so hopefully that's the biggest hurdle we can get over, but there's obviously a couple downsides to installing a conservation ditch where a traditional ditch currently exists. So overall, it's a program that will pay for drainage improvement. And the reason the state's paying for it is because if we do the conservation ditch, we get water quality improvements to the system as well, which is really what the purposes of the funding is. So in general, when we talk about conservation ditches, we are going from this top picture on the right here, we're going from the standard trapezoidal ditch that has been built since the 1840s and 50s on and works well when it's full of water, but most of the flows that occur are not ditch filling water. And we are simply expanding it. We are widening the top banks and we're increasing the cross-sectional area. Okay. Anytime you have a system where you have a drainage path and you're increasing cross-sectional area, you're going to lower the energy of that water for any given storm that moves through the system. And doing so creates kind of a dual situation where you provide an inset channel or a flow path for the smaller flows, and then as well as an overall floodplain like situation where you have benches where you have higher flows can spill out on top of them and still keep a lower energy gradient as it moves through the system. So we're starting on the top right picture with the standard trapezoidal, and we are converting it to one of the two types of conservation ditches down below, these two pictures down below. The first is a two-stage ditch design, and the second is a self-forming ditch design. I'll talk about the differences on the next slide, but you can see there that there's one big difference, and that has to do with the bench establishment after construction. But again, the purpose of these is to create a system that better mimics Mother Nature's natural processes. You go to any stream of any size, and it's going to have a smaller channel that's going to have an ordinary high water mark, and there's usually a floodplain attached to that that can let it spill out and widen the flow path as it gets bigger storms that move through there. That's the idea here. Okay. But the other thing is if properly designed, the two-stage design specifically can be designed such that the system's in kind of equilibrium. So what that means is that inset channel will move over time within the confines of the ditch footprint, and it'll slowly erode some of the floodplain benches, and then it'll deposit sediments on the other side, and it'll kind of move and get a little bit of sinuosity to the flow. But essentially you're in a quasi-equilibrium state where overall sediment dropping out from the watershed should be less than what was before. We have a large ditch dip out program in Ohio, ditch maintenance, and some ditches we dip out every few years. Some ditches we don't have to dip out every 30 or 40 or 50 years, but it depends on the situation. So converting a traditional ditch that you might have to dip out frequently to a conservation ditch, the dip out's going to be significantly less frequent than before. Okay. There's other benefits from the ecological standpoint, having a smaller inset channel, getting some hydrophytic vegetation in the self-forming channels to start out with, building the benches in the self-forming with sediments from the watershed that are highly productive. All these things kind of result in an after situation that is a net positive for the ecological system that's a part of a ditch. And there are ecological systems a part of every ditch out there, whether you want to think that or not, they're there. And so installing a conservation ditch helps to improve those situations as well. So, all right. This grant in general has really a couple requirements. The last 2 years, and I'll get to this here in a second, I guess. I'll stick with the first requirement. The first requirement is the project you submit in the application form. We want to make sure the watershed that the ditch serves is mostly ag land. Now, there's no percentage attached to that, but we're the Department of Agriculture. We help farmers and producers in ag land. We want to make sure we're treating the ag runoff through the system. Number 2 for the requirement, again, I just went through these. It needs to be either of the two types of conservation ditches, the two-stage or the self-forming ditches. Okay, I'll talk about how those are designed more specifically later on in this webinar, but those have to be in the application. We have to be converting or constructing a ditch that meets those two types of designs. Those are the two big requirements. The previous 2 years, there was another requirement that stated the finished product would have to be placed on the county drainage maintenance program. We're no longer going to make that an absolute, though we still really want to fund projects that will be on the maintenance program after completion, because we want to have some surety of the funds that we use to construct this ditch is going to be on a perpetual maintenance program and be able to take care of if there are any bank failures or odd things going on that need touched up. We like the ability for the county to go in there and fix them. Again, there should be less fixes structurally over time with these types of ditches compared to the standard trapezoidal type, but if there are those, we want to make sure that they're fixed. So we are going to open it up this year for projects that cannot be placed on the maintenance program. Either they can't get the landowner buy-in, they can't get the county to go through the process, whatever the impasse was in the first two previous years to put it on the maintenance program. We are going to open it up. And I know there's a significant amount of counties in the state that are just not familiar with the ditch petition process. And so that was a big impediment to getting those kinds of projects out there. So for this year, we'll see how it goes, is we will open it up to those ditches that will not go through those processes. And ideally, that should be less impasses. So keep that in mind. We still want them to be on a maintenance program if they can, but if they can't, they're not absolutely excluded from this program. We do have a set, the funding for these. Terry went over a little bit of the H2Ohio funding. We'll also anticipating getting some more federal funds down the road. So the funding source could change, whether it's going to be the state or the federal or other pools of fundings, but that may dictate which projects we fund with the federal funding and the state funding based on whether or not it's going to be placed on the maintenance program. So you don't really have to worry about that. Just know that if you can put it on the maintenance program, please do. If you can't, you can still apply and we can still put it in the application pool to see if we can fund it. That's the big change from this year compared to the previous years. All right, so to get a little more specific, I talked about the two-stage of the self-forming. The big thing you need to know is that the top width compared to what the traditional ditch was is 2 to 4 times wider than what it was before. So there's obviously a much larger footprint that's typical with these projects when they're installed on a traditional ditch system. Okay, obviously that's a taking of land. There's some acres, and if you go per mile, maybe it's only an acre or two, but there is some amount of land that's now taken out of production because of the installation of a conservation ditch. And that's the number one impediment, aside from the cost, that we get with putting these out on the landscape, is trying to convince producers and landowners that the taking of the ground is going to be an overall net positive for their farm fields and for their watershed benefits. But the two-stage, just to drill down a little bit deeper here, is when we widen the top width, we're going to essentially dig out the banks to whatever width the equations require, and we're going to do that down to a certain depth above the design grade. Okay, so there is a certain depth here, 1 to 2 foot or so, that we are going to leave the benches. This will be standard subsoil when you pull the benches back for the first time, and we're going to leave those there, and that acts as the floodplain for the larger storms when it spills out of the center channel. Okay, the self-forming ditch is the exact top width. There's no difference between the top width of the two-stage and the self-forming ditches, but we are going to remove those benches all the way down to grade. We're building an over-wide trapezoidal channel, and I just told you trapezoidal channels have a sedimentation issue, especially in Northwest Ohio. So why do we build an over-wide one? Well, we want to encourage additional sedimentation, and there is a big benefit when you really widen the ditch system. You really lower the energy gradient. You really encourage sediment dropping out from the watershed, and what will happen over time, within a few years, up to 10 years perhaps, we will build these benches naturally that will be built out of topsoil that has eroded from the watershed, so very productive soil types. Whereas up here in the two-stage, these are going to be subsoils that have been exposed from pulling the bank back. So these benches that are going to be formed over time from the self-forming situation is going to be highly productive and very good from a water quality benefit, because not only do you get a lot of plant growth and a lot of microbiology going on there, but the sediment themselves literally came from the watershed that had phosphorus and nitrogen and other things attached to it that we're now storing in here from the watershed. So we prevented sediment from moving further downstream. And so that capture is significant in terms of phosphorus particularly. Well, when you're talking Western Lake Erie Basin, that's a big thing. So I'll say this, especially if you're in the Lake Erie watershed, we are highly going to recommend the self-forming ditch for the phosphorus benefits. If you're elsewhere in the state, we're more concerned about the nitrogen aspects. The two-stage ditch could be fine. If you have unstable banks, the two-stage ditch is probably going to be the way to go, because you still have those exposed benches there that kind of lock in the toe of the embankment. So two-stage ditches may be a little bit more stable after construction. Over time, the self-forming ditch will get there after it builds its own benches, but there's different places for each each of these types, but just know if you're in the lake area watershed, we highly recommend and suggest you do the self-forming ditch. And if you're elsewhere in the state, you can do either one of them, depending on your situation. So I prefer the self-forming ditches in most cases, unless you have weak soil situations and bank failure issues that could be expected. Okay, so this grant is going to work the same as it did the last couple of years. We have this application form. Bowden should have sent that out to y'all this morning. And I'll go through it again this year. There's only minor changes in it that deal mostly with the allowance of non-maintained ditches to apply. But I'll go through that again here in a little bit. But what we're asking for is this application form to be turned in with some preliminary information, where it's at, what size it is, and things of that nature. Okay, so this process, we are sticking with the only two entities eligible to apply are a county soil and water district or the county engineer staff. This is all 88 counties is eligible for this program. So this is statewide. I talked a little bit about the Western Basin, which is where we have the phosphorus issue, but this is a practice that is applicable for all water quality issues statewide. So that's why we're going to keep it open statewide like we did last year. But to continue working with the entities who are familiar with ditch projects, we want to stick with the soil and water districts or the county engineer. That's not to say they can't outsource the design and engineering to a third-party firm. That's totally fine. If some individual landowners are interested, they have to work through one of these two entities to do it. If an organization has some projects that they're interested in getting funded, that's fine. They still have to work through either the districts or the county engineer. So let's see here. After we get the applications, we're going to review them for an internal metrics. I'll talk a little bit more on the grant side of that when we get there. All things being equal, self-forming is generally going to outrank the two-stage, like I said, specifically in the lake area watershed, but that also might be the case outside. So I would prefer you start with that if you can. And then all things else being equal, the applications that say the ditch will be placed on the maintenance program after construction will outrank the ones that say they won't, for the same reason I explained earlier. Okay. The requested funds through the application will be reserved to ODA until after the construction is completed. And this is important because obviously there's contractors who are going to be building the ditch. They're going to want payment probably sooner than where you'll get your reimbursement from us from the grant. So whether it's a construction loan or bond, or you have county funds you can pay for the construction in the meantime, that's how you're going to have to handle this. Whether it's a maintenance ditch or not, it does not matter. If the contractor wants paid before we have sent the reimbursement funds to you, you'll have to figure out a way in the county to do that. So you have to consider that up front and figure that process out. When the engineering plans are finished prior to construction, we'd like to see those, not for approval of the plans or the design, but just to concur that what is planned on the final plans matches what was applied for. After the construction is completed, the applicants will submit the as-built plans as well as itemized bills of the project. And these itemized bills include costs that were directly attributed to the two-stage self-forming sections of the ditch, and then separate of the other costs that were occurred in sections of the ditch that do not or were not constructed to two-stage self-forming, to conservation ditch. So you can have a project where part of it is conservation ditches, part of it is not. That's fine. We're just only going to pay for the part of it that is in conservation ditches after it's completed. The only caveat, and I say this as truly the thing that we've only ran into so far, is we like to pay for anything it takes to make this project work. Rock structures, tile outlets, seating, different things like that are all important to the sections that are built to the conservation ditches. The one thing we won't pay for is bridges and other crossings. We don't want applications to send in a couple 100 feet of conservation ditch to build $1 million bridge. That's not the purpose of this grant. So if there are bridges, culvert crossings, things like that, those just have to be paid for through some other route. If it's going through the ditch petition process, you got to go through the standard assessment procedure to do those things. If it's not a maintenance ditch after it's constructed, then it'll have to be on the landowners to pay for those or some other funding source that you have. So that's the one thing we won't pay for with this grant. So after it's all over, we'll get the build amount and we'll compare the final build amount to what you applied for in the grant, and we'll pay whatever's less. So if you got it built cheaper than what you applied for, that's great. We'll just send a check for what it was built for, or vice versa. If the project cost more than what you applied for, will probably end up going up to that total amount of what you applied for, and then the extra would have to be paid for through a normal ditch assessment method or through the landowner if it's not on the maintenance program. Okay. So I'm going to go through the application form, and if you have this in front of you, great. Otherwise, you can kind of just listen to me through this part. The first part here is the application period. We are opening this up on August 1st, essentially today. So essentially today through the end of October. And that's going to be a hard deadline. So hopefully you can get some projects through this. The first part, if you have ditches that might be of interest in this program, is to talk to the landowners who own right next to the ditch. If they're not on board with it, then it's probably not going to go well. So get them on board with it first thing this summer. And if they're willing, then you can proceed with that through the application. But I'd like to start getting these in as soon as possible, and not everyone wait till the last minute. Okay, but that's the application period, is through the end of October. Terry went through a lot of the H2Ohio purposes and funding and what the future holds for us. It does sound like the funding for ditches is going to be around for a while, so that's good. Essentially, the grant basics, I'm going to open up my hard copy here so I make sure I hit everything that I get, but this is a reimbursement grant. Like I said earlier, we're not going to provide incremental payments for construction completion at certain periods throughout the whole process. It's going to be one big check at the end after it's completed, after you sent the as-built and the bills. Okay. The cost share is up to 100%. And I say up to 100% because if you did your estimate right, and there's no bridges and crossings and it's all conservation ditch, we'll pay for it all. Okay. So it's up to 100%. Project requirements in part 1 there. Again, I went through that. There are 2 types that are going to be eligible, the 2-stage and the self-forming ditches. We're not doing a natural channel design for a large stream or anything that's super expensive or odd like that. It's simple ag ditches that meet those 2 types of conservation ditches. Part 2 there, the ineligible H2Ohio conservation ditches, essentially is if it's an all urban area, we're probably not going to select that as well. And then if you use some other sort of conservation ditch design method that we're not familiar with or don't agree with, that would not be eligible either. Down to page 3 here, the allowable cost, staff time, essentially all staff time worked on the project is going to be eligible, except for time spent processing the grant. So time spent filling out the application form, time spent filling out the quarterly reports. Those aren't large, big pieces of work to do, but that time's not going to be eligible. Okay. But time surveying, design, time talking to the landowners, whatever you charge to your normal ditch projects, if you're familiar with that, that would all still be eligible for full reimbursement from the grant. Same with the earthwork, whatever it takes. If we're just going to take the earthwork, all the spoil, there's going to be a lot of spoil, and you're spreading that in the fields that are nearby, that's all eligible for cost reimbursement. If you're hauling the spoil off-site completely because you have nowhere to go with it, that's also eligible. That's going to be an expense that's going to add to the total cost of the project and may lower the ranking compared to a similar project of the same size that doesn't have that expense, but it's still eligible to be fully reimbursable. Okay. Structures and appurtenances, again, if you have tile outlets, rock chutes, different kinds of grade control, all that is eligible for full reimbursement except for bridges and other crossings. Okay. Seeding, normal ditch seeding mixtures are fine. That's fully eligible. Straw mulching, blankets, things of that thing are all eligible. Even a hydro seeding I wouldn't be opposed to if you think it's going to take where it is. Some folks have even done a native seeding on the banks. I don't normally recommend that, but if that's something that you've had good success with some other projects, we'd consider even calling those eligible for reimbursement. Okay, through the administration, section 4, I'm just going to highlight, there's one sentence here, if you can see my cursor, whoops, go back up here, where it says ODA, and this is really ODA, the state of Ohio in general, is not responsible for future maintenance costs. I want to highlight that because I don't care if you go through the ditch petition process or if you don't, if it's not on maintenance or if it is, at the end of the day, when the project is completed and we've released the funds, the state of Ohio is no longer responsible for maintenance of that ditch. And the agreement that you'll sign if you get approved is going to say that. So if you don't do that, you're going to violate the agreement, and then there's going to be other legal, issues. So keep that in mind, that we'll pay for the construction of a good quality ditch, but after that, it's on you or it's on the landowners, depending on which way it goes on the maintenance program. We talked about the eligible applicants, just the soil and water districts, just the county engineers. Again, if you have landowners that are interested, that's great, but they have to work through you. Let's see here, part C down to number 2. If in this application form, you'll see when I get to it here, there's a section where you'll say this ditch will be placed on the maintenance program. Either it already is on the maintenance program, or you're going through the petition process at the moment and it'll be on there after it's completed. We just need to make sure that that process is completed before we send the funds out. Part 2, the project evaluation. This is where, once I start getting the applications in, there are these factors that are all listed here is what we'll use to weight one application versus another. All things being equal, lower cost per foot is going to outrank higher cost per foot. All things being equal, smaller watersheds generally outweigh bigger watersheds. And I say bigger watersheds, generally conservation ditches are good up to 10 square miles. 5 square miles is really the ideal max, but up to 10 square miles is possible. And in anything beyond that, you really get into different types of hydrologic situations where the stream's not going to react as we would expect in a typical ag ditch. So I would say usually 10 square miles is the hard stop on that. And then all things being equal, again, the ditches, and I can't say this enough times, the ditches that would be placed on maintenance will outrank ditches that will not. So far, we've been able to fund all of the projects that have came to us the last couple of years, but if we get in a situation where we have more projects than funding, then we will have to start getting into weighting these factors. All right, down to page 5, the method of payment. I've talked about this before. This is a single reimbursement after construction, after as-builts, after the bills have been turned in. At the very end, you'll get a big fat check. So paying for the ditch to be constructed in the meantime is whatever method you can do legally, I should say, construction bonds, other county funds, whatever, that's fine. Just you will not get payment from us until it's all completed. Part 5, down at the bottom there, for the operation and maintenance, I talked about this before and I'm going to hit it again. If it's on maintenance program, future maintenance is just taken care of through that assessment method. If it's not on the maintenance program, then that's taken care of by the individual landowners, hopefully. Okay, frequently asked questions. I think before I'll do this, I'll just say that the projects that will not be placed on maintenance at the end of this, or after it's completed, we do have a set of extra requirements that will be placed in the agreement if you're funded. Similar requirements that we sent out with the application form this morning will be listed in the agreements for the projects that's not going to be placed on maintenance. And most of that has to do with quality control. So I'll talk a little bit about that more here in a second, but I wanted to hit that is that there are a few extra requirements that will be listed in the agreement if you get selected. Frequently asked questions. Can I make changes to my project after it's been selected for funding? If we get into a ranking situation, we have more projects than funding, it's going to be based on merit. If you change the merit after it's been approved, we'll probably have an issue with that. So do your due diligence to get the application form as close as you can to what you think the final project's going to be. Okay. Skipping down towards the bottom, will prevailing wage laws apply to ditch construction paid for through this grant? Generally, yes. Anytime you have a public improvements using funds for an infrastructure project, and you're using public dollars, generally you have to follow the Ohio prevailing wage laws. Okay. There is some language in the code that says if you're doing a ditch petition project and at least 75% of the cost is paid by private landowners, then you may not have to provide prevailing wage rates, and that's how most ditch petitions go because they're mostly paid for by the individual landowners. You don't necessarily have to follow those, but when you have a grant like this, it's probably going to be interpreted that you might. So every county should have a prevailing wage rate coordinator. If it's not with the county engineer, it should be someone in the county staff. Talk with them before you apply and before you put your estimate together, because prevailing wages will increase the cost significantly. We expect that, we'll pay for it, but I'd hate to see you in a position where you didn't follow the revised codes on that law in particular, because that would not be good for you. The last part there, are there any strings attached to the ditch after it has been constructed and the H2Ohio payment has been received? Not from us. Again, as soon as we send the money, we're washing our hands. It's on you if it's on the maintenance program, or it's on the individual landowners at that point. Okay, what happens if to unused funds after the project completed, if it was completed for a cheaper price than what was put in the estimate? Those are staying in the general H2Ohio fund pool. We have a general pool that we use for a number of things. And because we're not sending those funds out to you before the project's completed, there should not be any slippage of funds that you would have to send back to us. So those extras would just stay in the H2Ohio fund pool to be used for other projects elsewhere in the state. Can private landowners or group of landowners apply for this grant? We talked about that. No, they need to work through those two agencies to be able to go through this program. What additional management is required in conservation ditches beyond normal ditch maintenance? Okay, so I talked about earlier how there is expected to be significantly less dip out maintenance on conservation ditches. You know, if you have the two-stage ditch, it should stay roughly that same shape indefinitely. Now, theoretically, yes, but there's always situations where you have a little more sediment coming through than you expected, and so you might have to maintain it every so often. It's going to be significantly less than the before, though. So less earthwork for sure on the maintenance. However, you're now increasing the top width, the overall footprint of the ditch by 2 to 4 times. So you have 2 to 4 times of the vegetation that would have to be managed. So if your ditch program sprays ditches, you'd have to use some more herbicide for that. If you're mowing and you want to mow the benches, you'd have to take that into consideration. If you have a two-stage ditch, you can create access points to get down to the benches to mow. If you have a long arm mower that can get down there, that's fine too. Some people like to burn ditches. That's up to you. Whatever your normal method would be, but usually vegetation maintenance is a little more than what would have been the before situation of a standard trapezoidal ditch. Okay. All right. Are all sections of the ditch required to be on the conservation ditch design? If you send in an application form that has, 4,000 feet of what the ditch project's going to be, but only 3,000 feet is going to be conservation ditches, that's fine. We'll only pay for the 3,000 feet of conservation ditches. So it's totally fine to have like an interrupted section that's not going to go through conservation ditch construction. What if the H2Ohio grant doesn't pay for 100% of the project? And that's where, if it's going to be on maintenance, you go through your normal assessment procedure to the benefiting landowners. And if it's not going to be on maintenance, that would be up to the individual landowners, or if you have another county fund or another grant to pay for whatever the extra cost is, that's fine too. But it's up to those folks to figure that out. So yeah, if there's any costs that the grant doesn't pay for, or that's over the grant amount, those would be up to the county to figure out whether it's the individual landowners or the benefiting watershed to pay for. All right, let's move on to page 8. This last one I'll go over here is been one that you'll probably deal with if you're dealing with a ditch. What if the ditch has an existing CRP buffer or other easement along the top of the bank which cannot be easily moved? The answer is, if it's CRP, if we widen the top width here and we take out some CRP buffers, what happens is the FSA office will either cancel those acres we've taken out and then check with NRCS to make sure that the remaining acres still meet the minimum. And if they do, usually that's okay, not a big problem. But if the remaining acres does not meet the minimum, I mean, it's not 30 foot wide or whatever other situation NRCS determines doesn't necessarily meet the minimum requirement, what FSA will do is cancel the entire contract for the entire buffer. Now, when that happens, generally, the landowner who had the CRP contract is required to provide the refund for the payments they received on that buffer. And so that's not an ideal situation. In that rare case, I'll say, that occurs, you know that's going to occur, you can provide the amount of funds that would take to refund CRP in the grant, and we'll consider that an eligible reimbursement amount. But generally, what happens is when you have a canceled contract due to some unforeseen issue, in this case, the county was building a two-stage ditch and they took the buffer. Generally, you can appeal to the county committee through FSA, or in some cases, the state committee, and they'll just waive the required refund for the loss of acres, okay, because there was some unforeseen circumstance that the landowner couldn't necessarily control. So there is a process to waive that total refund from the CRP, but you have to check with those FSA county and state committees. If the contract is canceled and if you don't have to provide a refund, you can sign up that ditch for another buffer on the now new top edge of the finished conservation ditch. So if you cancel contract because of this, you can sign up for an additional buffer outside of that, assuming CRP is still open. Okay, so the take-home message for the engineers and the designers for this stuff, that if you're going to be applying for this grant, make sure you talk to the landowners and see if they have a CRP contract. And you might even talk with the Soil and Water District. You might talk with NRCS or FSA just to double check with this, and get in contact with those folks prior to this and let them know that this is a thing that might occur, that they might have to deal with if this goes this route. Okay. The section below here, I'll talk about these equations in a little bit, so I'll kind of skip forward on the application form here now. This page 9 kind of gives a summary of the timeline of what we expect. Again, the sign up application deadline is the end of October this year, this fall. We're going to review those for the next month or so after that, and we'll send out approval letters between December and February, and those will come with the agreement that we send to the applicant to sign and get in place for approval of the project. After that's done, you can go through the normal methods of designing and bidding and constructing the ditch, and you have until the end of 2026. So this is now 2024. You have until December 2026 to complete the project and get the reimbursement. Now that's a hard-ish deadline. If certain things fall through and it gets delayed a little bit, we can always push that back as needed, provided that you are making progress on the project. Okay. Okay, so sheet 10 here, this is where we get into the first 9 pages of this application form do not need to be turned in when you turn in the application, but these next preceding 9 or so pages do have to be turned in. This first one here is just the general information, who you are, where you're located, and the contact information for this project. And then with that, the ditch name, the H2Ohio location that it's in, what type of conservation ditch are you going to design for this project, where it's at, the total funding request, so the total dollar amount that you are requesting us to reserve. And then this question is new this year because we are going to allow or consider applications of projects that will not be placed on the county maintenance program. We want you to answer this question: is if you do this project, is it going to be on the maintenance program after it's completed? Okay, that's a yes, no. And that's how we're going to put these projects applications in a couple silos to figure out what funding pool we might use and which ones might outrank other ones based on that single detail. And down below there, you've got general project details. This is really what I use to start to weigh projects back and forth: the total conservation ditch length, the total watershed that it treats, and the start to finish dates and permits or things of that nature at the bottom there. Form 2 is general information about the estimate and what you're going to break down the bills into. Again, staff time's eligible, but for the processing of the grant application form and taking care of the actual grant itself. Cost of engineering design services: if you don't feel capable of performing the engineering design, construction, inspection yourself, you can outsource that. That's fine. That's going to add a little more extra cost to the total project. So all things being equal, cheaper projects are going to beat more expensive projects, but that's not to say that we can't provide a cost share for. We've already done that in a couple cases on previous years. You can kind of see all the other things there that are eligible, and the things that are not eligible: bridges and other crossings. But we're also not going to do trail constructions. We're not going to do workshops for a field event or anything like that. The costs are just for the implementation of the project, if you think of it like that way. That's what we'll consider eligible. Part 3 there, you can either use this chart to break down your estimate, or you can create your own spreadsheet. As long as your own spreadsheets and your own forms that you're going to develop for the application form, make sure that they're attached to this in a single PDF with everything else in here, so that I don't have to go through multiple PDFs when I start reading through things. Form 3 on page 13 here is some additional information questions. I'm going to go through here real quick the standard tri-state design method equations for the conservation ditches. If you choose to use something else other than those, you need to justify it to me. You need to state your case as to why you're using that versus these standardized equations that I'm going to go over. And then just in general, what kind of permits are required? All ditches, you could have permits through a floodplain coordinator, through the Army Corps, through EPA, whatever it is. If you have an idea of what you'll need, put those down there so it gives us an understanding of what the scope of the project is. And then the last one there, do you mind if we share this proposal with other parties? Oftentimes there are research efforts that would like to study some recently built conservation ditches. We have a couple going on at the moment, actually. So that's just saying you're okay with us sharing the information with those sources so that they can contact you if they're interested in studying your project or doing something with your project. Okay, sheet 14. This is application form number 4. This resolution of authorization is mostly for soil and water districts, and essentially it's the Soil and Water Board giving the power to go ahead with the grant to the district administrator or the district technician. It's generally what it's used for. Not every district does this kind of a process or even requires it. And you don't have to use this form specifically, form number 4. You can create your own, that's fine too. If you're a county engineer and you think you want this from the county commissioners, or if it's someone on your staff, and it's just a different way to make sure that the person that's actually on the grant has the authority to go forward with it. This is not an absolute requirement, but if you want to use it, you can. Okay. Form 5, for the projects that will be placed on the maintenance program. Again, I had that on form number 1. I had the little yes, no box if it's going to be on maintenance. If it is, we want to make sure the county commissioners are aware that you're applying for the grant and they're okay with it. You can use this form, you can get them to write something else up, but essentially it's like, hey, we're going for this money to do this conservation ditch. We're going to put it on the maintenance program. Do you generally agree with that? And if they do, put it in writing, get them involved up front. You don't want to blindside county commissioners after you've already gotten approved from the grant and you're ready to build it and they're not in the loop. So just make sure you keep them in the loop. You can use this form, use some other form that you want to create on your own, that's fine, but I will need to see this or something else in writing if you check a yes on that box if it's going to be placed on the maintenance program. So something like this or this will have to be turned in if it's going to be on the maintenance program prior to approval. Okay, so if I don't get it, I'll be asking for it if you don't send it in. Okay, page 16, we're getting close to the end. This will kind of be most of what I'll talk about with the application form before we're done with it. What else I will need to see in the same PDF single attachment is a plan that clearly shows where it is, clearly shows what sections are going to be conservation ditches, and anything else. If you have grade control structures, you have easements in the area, you have pipelines, whatever that's going to be important to see, put all those on the plan map. This is not an engineering plan. This is simply a plan map of where it's going, where everything's going to be located. You do not need to do engineering plans for the application. Those can come after you've been approved. This would be sometime 2025. Okay, so don't put all your effort into engineering unless it's going to be same way all the way through. I just need a plan map. Okay. And then number 2, I also need to know the design method you chose. If you're doing a 2-stage, what floodplain width did you choose? If you're doing self-forming, did you choose the floodplain width of 3-to-1, 4-to-1, 5-to-1? And show me a cross section on there too that generally says the depth might vary, but the bottom widths are going to be 10 feet for this section, 14 feet for that section, because you have 2 different branches. And then when they come together, maybe it's going to be 16 feet. just show me that you've at least went through the equations and you have a general understanding of how they're supposed to be interpreted. Okay, let's move on here. I'm going to skip over page 17. You can read the steps to complete it, but I've went over most of that already. And the last page is just a check sheet to make sure you have everything in a single PDF sent to me when you apply. Okay. That's it for the application form. I talked a little bit about the additional requirements that will be in the agreement if you're approved, if you're not going to place the ditch on the maintenance program. And again, most of those deal with construction quality control. We want to make sure that everything is inspected properly, everything's being constructed properly, and then the finished product, when the as-built are done, everything is the way it was designed to be. Okay. There's also some additional smaller legal sideboards. You can read through the draft list we sent out in the email this morning. I can't promise that everything in that draft list is going to be in the final agreement. We still have to work with our internal legal team, and I can't promise that there's not going to be additional things, but that's generally what it is it kind of sets some additional sideboards because it's not going to go through a standardized revised code process like if it was going through 6131 or the 940 code. We just want to make sure those are in place so that we have some belief that this ditch is going to be properly constructed and taken care of, and it's not going to cause any odd issues on the legal side for us. Okay. The last 2 years, like I said, we had signups in 2022 and 2023. We had 23 total approved projects, and 15 of those was the self-forming design, which is good. That's what I like to see. They total in $6.5 million and 13.6 total miles of conservation ditch. One of those 23 projects has already been completed. It was our first one. It was completed about a month ago, and it went very well. And I'm expecting to be about 4 or 5 or 6 more completed by the end of this year. So these processes, you know, they take a couple years to get fully completed. And so we're starting now to get into where the first sign up from 2022 is going to be completed. So I'll have some more information on that, but things are going pretty well so far. So far, just to give you an estimate, this is heavily dependent on watershed size and the depth of existing channel. But on average, the costs have been coming in $90 per foot. That's roughly $500,000 per mile. So, and again, the cheaper side, we've got some $32 per foot. Those are going to be the smaller watershed. The bigger ones are going to be the bigger watershed. And then when talking about water quality, comparing apples to apples from one best management practice to the other, conservation ditches, particularly self-forming ditches, are extremely efficient at taking out phosphorus. And I'm talking on the order of about $100 per pound of P. Let me back up. It costs about $100 to take out a single pound of phosphorus in the self-forming channels, just based on construction costs. And you might think that's high, but you should know that almost no other ag BMP is anywhere close to that low of a number. Most of them are in the several hundred to up to $1,000 to take out 1 pound of phosphorus from a system. These things are extremely efficient. And when you build a overwide self-forming ditch and you want to dip those benches out to start the system over again to catch even additional phosphorus, then costs go way down on per pound phosphorus. So we're really excited about the self-forming ditches, like I said earlier, from a phosphorus improvement standpoint. Some of the challenges we've had so far is obviously you're going to take up some land from a landowner and convincing them that it's the right thing to do. It's going to improve the situation. We're going to pay for it. Generally, landowners who want drainage improvement are willing to listen to you. I need people out there selling this on the ground. So hopefully this convinces you to do so, but getting that first hurdle of getting them convinced is the first step prior to this application process. If you go through the maintenance program, assessments are always a question. Do you assess it based on what the actual cost was to the county, to the construction cost? Can you keep ODA off the schedule of assessments, which you will if you're going to sign an agreement through us? What's the base of it for the assessments? You know, all those things are questions. I think we've pretty well ironed those out over the last couple of years, but there has been some of those questions pop up now and then. If it's under the existing maintenance program and you're going to construct a ditch that's already on maintenance, do you have to have another hearing to increase the top width? And there's a question. Some prosecutors think you do, some think you don't. I'm not going to give you an answer one way or the other. I lean towards that you wouldn't have to do that if everyone's in agreement and it doesn't cost extra money to the watershed, but I'm not a lawyer, so please don't use that in court. Sometimes ditch construction inside floodplains require H&H studies. If it does, those costs are fully eligible for reimbursement for this project. Other kinds of studies, like an ecology study, wildlife study that maybe ODNR would want as part of a petition process, I'm going to say generally not, depending on what it is. Some of those can get quite expensive and maybe probably aren't necessary for the project. I know some of you county engineers have dealt with that in the past, so we'll stick with just the hydrology studies that could be impacted via the construction of a conservation ditch versus a typical ditch construction, and try to avoid some of those other studying costs as part of the grant. All right, we talked about the funding, paying the contractor prior towards completion. That's up to you to figure out. I'll stop there. Is there any questions, Bowden, in the chat? I didn't see any come in, but I could have missed them.
Yes, good timing, Justin. So we did have one question come in just asking for you to repeat the desired drainage area, the maximum drainage area, et cetera.
Yeah, so 10 square miles for a conservation ditch is generally the max. Any more than that, and you get into different types of hydraulic situations that aren't really expected in a normal ag ditch situation. So don't go to the Maumee River and want to turn that into a two-stage ditch. Now, obviously, that's an extreme, but generally 10 square miles or less is applicable. And I would even say 5 square miles or less is desired. Not to say you couldn't go over 5 square miles, but the smaller the watershed, the better, down to a couple hundred acres. Anything smaller than that, and it's really going to be a linear wetland. It's not going to have enough energy to build its benches. But I would say generally, if you're between, let's say, 300 acres and 3,000 acres, that's going to be the sweet spot. So anything else, Bowden?
Not at this time. Does anybody have?
Okay.
Raise your hand is another option, but I think we can proceed for the moment.
Well, that's the application form and what I expect. What I'm going to go over now is a little bit of a training that I went through the last couple years on how you actually design a conservation ditch. And it starts with the regional curve design that folks from OSU put together many years ago, actually. And this is a standardized design that works well in Ohio and in just about all parts of Ohio. There may be some exceptions, and if there are, we can talk about those on your specific application forms. But generally, all Northern Ohio and Western Ohio falls in this case. And the way this works is for the two-stage, let's focus on the two-stage equations for a second, because that's what these self-forming equations are based on, is we have this width and this depth. Well, what are these widths and depths? It's not top width and it's not overall total depth. This W is the top width of the inset channel design. Okay, it's not the width of the final overall conservation ditch width. It's this little width right here across the top. All right, and you plug into the equation, you have a standard coefficient here of 6.9 times the drainage area in square miles. That's important because you push in whatever the acres are, it's going to give you something absurdly large. I'll just say from a normal mathematical process, make sure you take the drainage area in square miles to the power of 0.42 before you multiply by 6.9. There was a couple errors on that. People had questions on the last couple of years, but just make sure you take that to the power before you multiply it. And then the depth, again, is not the total depth of the ditch. It is the depth of the bench, the height of the bench above the grade line down here. So from the bench down to the bottom, it's usually going to be between 1 and 2 feet, depending on the drainage area. But again, it's based on the same drainage area in square miles. It's just to the power of 0.32 instead of 0.42. So those equations give you this width and that depth, which establishes the bench height. And then you need to figure out or choose the floodplain width, the overall bench width, flooded width, I should say, which then will dictate what the bench width is. The flooded width, as soon as the inset channel goes to the bench elevation, the flooded width that spills out all the way to the toe of the banks should be 3 to 5 times the channel top width here. Okay, so whatever W is, multiply that by 3 to 5, 3, 4, or 5, if you want to think of it that way. And that's what the floodplain width should be. So it shouldn't be any smaller than 3 times W, and shouldn't be any bigger than 5 times W. 4 times W is perfect, right in the middle. And then your bench width is simply whatever that overall floodplain width is subtracted by the top width of the inset channel, and that's your overall bench width on both sides. Okay. Now this bench width, if you're doing a two-stage design, it's ideal to have a bench width on both sides and not do a total one-sided construction. In other words, don't put all of the bench width on one side and then have the other side go straight up from the bottom of the inset channel all the way up to the top of the bank. Do not do that. You want a little bit of inset channel or a little bit of bench on both sides so that the toe of the ditch is protected. Okay, you could get some undercutting if you didn't do that. So generally 25% is the minimum of the total bench width I would put on one side, but it's up to you to figure that out, which way you want to go with it, but just be careful.
Justin, before you move on, we did have someone raise their hand for a specific question on that slide.
Sure.
David Kuntz, you should be able to unmute yourself.
All right, thank you. My question was actually on the phosphorus load reduction. You noted that it was for self-forming ditches only. Do you have any calculations on the load reduction for a two-stage ditch?
So the two-stage ditch is tricky to nail down when it comes to phosphorus. Some of the studies that have shown phosphorus reduction have come from stream systems that were degrading systems. And so we went from a degrading system and we stabilized it. So in other words, a system who was losing more phosphorus than it was gaining from the watershed. And then we installed a two-stage ditch and we stabilized it. And so we then went into quasi-equilibrium. And so we had a net positive loss reduction in those situations. And that's where most of those studies who have noted a phosphorus reduction came from. In Ohio, and I can speak specifically towards the Western Basin, this may not be true for all of Ohio, but mostly in Ohio, we have energy systems and ditches that do not result in a degradation system. It's more of an aggrading system that the system catches more sediment from the watershed than it would transmit downstream. And that's why we have a ditch maintenance program, is because we fill up with sediment and we have to dip it out every now and then. So to say that we're going to go from that to a system that's now two-stage and now we're in equilibrium when we don't have to dip it out so much that we would have a similar phosphorus reduction, I don't know that I'm willing to say that. So there is a small reduction we may be able to attribute to a two-stage system, but likely it's going to be far less than a self-forming type of a design that actually catches sediment in a significant volume. So that's why I didn't include those to this type of a calculation, if that makes sense. Hopefully that answered your question.
Yeah, thanks a lot.
Yep, no problem. If you have more questions on that, you can contact me after this. We can get into the details of how those calculations work out, but that's typically how I do it. Okay, the current channel inset size will probably be different from the inset channel size, and what we're saying there is if the trapezoidal ditch was there before we did a two-stage ditch, the bottom width is likely going to be bigger, could be smaller, but it's likely going to be bigger than the bottom width that would result from the inset channel width, and that's okay. You don't have to construct a bench to this exact dimension. So in other words, if the existing ditch is 15 foot wide and this needs to be 10 foot wide, you can just leave it 15 foot wide. That's okay. But it's likely not going to be the same, and that's all right. You just want to make sure you have the minimum top width established by that inset channel top width, okay? When it comes to the bench depths, generally this depth is a hard line. Don't go any deeper than that. Don't make the benches any taller than what this depth equation is. So if this depth equation spits out a bench depth of 1.55 feet, do not make it 1.6 feet. Do 1.5, or you can do something less than 1.5. That's okay too. If you build a bench less than what this depth requires, what's going to happen is assuming the equilibrium is where this height is, it's going to build there over time, and that's okay. But if you build one taller than that, you're going to have odd energy systems that's going to start to erode and cause issues elsewhere in the bench, and it's not going to perform the same sort of function that we would like to see from a two-stage ditch. So just keep those things in mind. All right, for self-forming, these three equations here are these same equations right here for the two-stage ditch. They're just rearranged to get an overall bottom width, so that we're building like an overwide trapezoidal design. These equations simply tell us what the finished bottom width is. This is really easy to construct when you have a trapezoidal design. You just have to know the bottom width and the depth you're going to put it onto on grade, and then get a side slope, whatever that is. The only caveat with these equations, and it's the same drainage area in square miles, same powers, but the only caveat is these three equations were developed assuming a 2-to-1 side slope that comes all the way down to the bottom. Okay, so if you're going to use a self-forming design and you're going to use a 3-to-1 side slope, let's say, you will have to go back to these original equations in the two-stage ditch, and you'll have to kind of rearrange them so that the cross-sectional area will match a 3-to-1 side slope. If you can't do that, if you're having struggling with that, call me and I'll do it for you. But that's how these were put together. The 3-to-1, 4-to-1, 5-to-1 is the flooded width that would have occurred if this was a two-stage ditch. So that's what those are. Those are not side slopes. That's important to understand, is that a 3-to-1 equation is going to give you a smaller bottom width than a 5-to-1. Okay. But as long as you're somewhere between those three, it's going to be sufficient for this program. All right, let's go through a quick example, and I'm running out a little bit of time here. We got 20 minutes left, but let's assume for the sake of this example, the watershed is 2.5 square miles. The design grade is 0.1%. The existing condition is a standard trapezoidal ditch that was built in the early 1900s or whatever. It has a design bottom width of 8 feet, a depth of 5 feet, standard side slopes of 2-to-1, and a top width of 28 feet. And if you plug all that into the Manning's equation, the existing capacity of that ditch is 218 CFS. And for that size of a watershed, that 218 CFS of capacity falls somewhere between a QA and QB. This is extremely common in ag ditches. If you're not familiar with the QA flow is and a QB flow is, it's the standard SCS drainage curve type of equations we use for ditch design. You don't need to know much else than that. If you have some more questions on that, I can answer that offline here. But generally, QB is the minimum we would design a ditch for ag purposes in Northwest Ohio, in most of Ohio. And this ditch carries at least that, okay? But it doesn't carry even a 1-year storm or a 2-year storm. All right, so let's go through this example, and let's say we're going to turn that existing ditch into a two-stage ditch. We plug those into those same equations, 6.9 times the drainage area to the power of 0.42, and we get a inset channel top width of 10.1 feet. And from that equation of 1.0 times the drainage area to the power of 0.32, we get a bench height of 1.3 feet. We chose our floodplain width to be a 4-to-1 ratio of the width of the inset channel. So that means 10 times 4 is about 40 feet. Doesn't have to be exact, somewhere in the ballpark's fine. And then with the depth of 5 feet to the grade line that we had in the existing conditions there, that gives us an overall top width of about 55 feet. And you plug that into the Manning's equation, and we get a bankful capacity of 450 CFS. So significantly more than double what the existing condition is, which makes sense. We're taking an existing ditch, we're making it wider, we're increasing the cross-sectional area. That's going to increase the capacity just from that process alone. If, however, we did the self-forming ditch, we stick with the same 4-to-1 floodplain ratio equation, and we plug everything in. We get a bottom width of 35 feet, and at that same top width, again, it's the same as a two-stage, the same exact top width. It's just a little more dirt to dig out because you're going to take the benches out. It's 55 feet top width. And because you have even more cross-sectional area in the self-forming design, you have an existing bankful capacity after construction of 655 CFS. So if we list all that out, You can see the comparison from the existing ditch to the two-stage ditch to the self-forming ditch. Again, the finished top width of both of them are 55 feet about, which is roughly double the top width of the existing, which is pretty good. 2-to-1 is good. Sometimes conservation ditches can be significantly wider than that, but that's not too bad. And you can see the capacity difference, obviously, because we're increasing the cross-sectional area. And because of that increased capacity, we also are able to now store at the bank full flow. We can now store the Q1 flow for the 2-stage and the 3-year storm for the self-forming design. Okay, and you can see the additional estimate earthwork for those types. Obviously, there's going to be more earthwork for the self-forming because you're taking out the benches, like I said. An important thing to keep in mind is that if you build a self-forming ditch, it's called self-forming for a reason. You're going to self-form those benches over time with sediments. And so over time, this cross-section area will get smaller and go towards more of the 2-stage quasi-equilibrium state. And we'll get closer to this capacity, which is still significantly increased from the existing conditions, but it should not stay at this final capacity. Now, if you go back and you dip those benches out, you're going to be back at that 655 CFS capacity. So that's up to you if you want to do that. All right, so this is just a cross-sectional view of what that example shows. The black is the existing ditch, 28-foot top width, 5-foot depth, bottom width of 8 feet, 2-to-1 side slopes. And then the blue is the 2-stage ditch cross-section that would be built. And then the red is the self-forming ditch cross-section that would be built. And you can see the top width are the exact same on the red and the blue, the 2-stage and the self-forming. The only thing I'll say is on the on the 2-stage ditch, you'll see that this requires the bench or the inset channel top width of 10.1, like I said earlier, to be narrower than what the existing ditch is. So this would say that you would put some fill in here to get that 10.1 feet. And what I said earlier is we would not do that. We would just essentially cut down to this section, and then that would be over wide. So that ultimately would be, 12 or 15 feet from that point to that point. And we would not add any fill because the fill would just not be very stable and it'd wash away. So keep that in mind. All right. That's it for the example. I will leave you with some contacts. Obviously, if you have any questions, you can call me, you can call Bowden. The two of us are going to run this program for the foreseeable future. Clark, if you have a contract with us and you're curious about how funding works, you can call Clark. If you have some design questions or issues, you can call me, send me an email, or you can go right to the people who I would go to. John and Jessica are the experts I use, so they're very good about helping you out if you have any types of odd questions. All right, that is it. I'm going to end this by kind of saying the same thing I said when I started. We're paying for ditches. We're paying for increased capacity of ditches, but the reason we're doing that is because we get additional water quality benefits, significant water quality benefits. So if you have folks who are looking to do a ditch project, but they're concerned about the money for the watershed, this is exactly what I want to shoot for those kind of projects. So that's all I got, Bowden. Did we have any additional questions?
Just one, which I believe I answered, but in case not, there was a question, does the ditch have to be located on ag parcels? So I'm not sure if they're talking ditch adjacent or if they maybe just missed your original comment on watershed. But.
Right. So in general, we want to treat the runoff from ag land. If the ditch is mostly an urban, but the watershed's an ag land because it's on the edge of the urban town or something, I'm sure we could probably make that work as long as we got enough room to do it. Think of it that way. We want to treat as much ag runoff as possible. So wherever the ditch is, most of them, it's going to be in the rural setting, but I'm not saying that it could not also be in the urban setting. It's possible. But the goal is to treat ag runoff that moves through the ditch. So I hope that helps.
Great.
John, I see you're on the call. If you are able, and if you have anything else to say, you can chime in if you'd like. Terry, same with you. I don't know if Terry's still on the call or not.
No, Justin, I think you covered it all. You did a fantastic job. If people want to follow up with any other questions for me, or have more interest in the water quality, research results, we'd be happy to provide those. But otherwise, well done.
All right. Thanks, John. Is Terry still on?
I
He
don't
must not
believe
be.
so.
Okay. All right. Well, then that's it. If anyone else has any last minute questions, we can get to them. Otherwise, call me anytime. Like I said, this is the people to call. I'm happy to help, and I hope we get as many projects as possible turned into us, but we'll wait and see.
Great. Thanks, Justin. Well, we've covered all the content, so I think we can go ahead and close down. Thanks, everybody, for joining us this morning. And again, please feel free to reach out to us.
See y'all later.